We're going to look at this last topic in hypothesis testing called type 1 and type 2 error. To use a hypothesis test appropriately, we need to consider the types of errors that can result from a decision that we make. So in order to understand each definition, we need to set up a situation and run a hypothesis test to better understand what is occurring. Okay, so type 1 error. Now here's the situation. Looking at a particular airline's record, it shows that during the summer months, 78% of the scheduled flights arrive on time. The airline looked at its procedures and has adopted some new procedures that they hope will increase the on-time arrivals. All right, so if we're going to run a test, we're going to set it up this way. Let's just, right now, the airline's on-time arrivals is 78%, and we're hoping the new procedure will, on average, increase that some number above 78%. And we'll run this test with 3% significance level. A type 1 error occurs when we reject the null hypothesis, when in reality it is correct. So that is what a type 1 error is. We reject the null for the alternative, but in fact, the null is correct. For the airline situation, what would need to happen for a type 1 error to occur? What do we need to have happen? Well, one thing that will have happen, so if I can go into a little more detail, is the p-value, or I should say, let me start with will be greater than 0.78. In other words, we landed somewhere to the right of 0.78, okay? And the p-value will be less than 0.03. And why am I saying this? Because a type 1 error occurs when we reject the null hypothesis. So right now I'm just concentrating on that part. And for the airline situation, what would need to happen for a type 1 error? Well, we need to reject the null hypothesis. This means that p-hat will be greater than 0.78 and the p-value will be less than 0.03. Okay, that's the mechanics of it, right? But let's now get into the ramifications in this scenario. So we will find enough evidence to our procedure has increased the on-time arrival to some value greater than 0.78. But when in reality, it is correct, we will find enough evidence to say our procedure has increased the on-time arrival to some value greater than 0.78, when in fact, the procedure has done nothing. And P continues to be 0.078. Should be 0.70. Right. So that's what would have to happen if a type 1 error does occur. All right. So now the question is, what is the probability of a type 1 error for this airline situation? Let me draw a picture here, because we need to make sense of this. So here's 0.78. And there's some value here, which I'm not sure what it is, but this area right here, this is 0.03. So there's some critical value right here that separates the lower 97% from the upper 3%. So what are we after? Well, we're after this probability of reject p equals 0.78 incorrectly. Okay. And this will be known as the probability of a type 1 error. But what is that error? Well, we just need to look at this picture. The only way we can reject is if our p-hat values, so these are all p-hat values, this is just a line of p-hat values, but the only way we can reject is if our p-hat value lands somewhere here. That's what will cause us to reject this value. But notice, is this possible even if this is correct? The answer is yes. there's a 3% chance that a p-hat value will land here. And of course, this number is part of that number. There is then a 3% chance that we are going to reject the null hypothesis incorrectly. So I'll let you kind of think about that for a second. So remember, the significance level was touted as amount of evidence needed to reject null. But all this means is that we reached a situation where it's not very common for it to occur. So we, instead of believing that we experience something very rare, we're going to believe that somehow this is not correct. And that's why we're experiencing something that is rare. But could it happen even though this is true? Yes. So if we reject at a 3% significance level, there's a 3% chance that we're going to be committing what's known as a type 1 error. That's the thing. These values can occur if p is equal to 0.78. Okay, so this is known as a type 1 error. So let's look at another situation. At a community college, proportion of first-year students that enroll in fall, winter, and spring terms and persist for a second year is 57%. Administration will implement a new course during the fall term that will be taken by all first-year students in the hopes of increasing retention for the entire year. The significance level will be set at 5%. So notice, remember, the significance level is denoted by alpha. And so notice I'll make a little mention here. So this is alpha. The probability of type 1 error is alpha, which is significance level. Okay. So this is our significance level, but it happens to be, again, the probability of type 1 error. So describe the null and alternative hypothesis for this. So let's see, for this one, it's going to be, the administration believes that it's 57% that persist after 1 year for first-time students. So if we believe that's true, then our null hypothesis is going to be p equals 0.57. Okay, and the alternative is going to be, well, we're going to implement a new course during the fall term that will be taken by all first-year students in the hopes of increasing their retention for the entire year. So we're hoping that somehow we're able to improve. The significance level, again, was set at 5%. Describe the null alternative hypothesis. So this is, again, the null alternative. What would have to occur to create a type 1 error? I guess I'll answer this question. What's the probability of a type 1 error? So the probability of a type 1 error will be, right over here. So probability of type 1 is 0.05. And now we'll describe what would this mean. So there's a 5% chance we're about to incorrectly reject the null hypothesis. But what would that mean? We find evidence that the program, the new program, has increased the resistance rate for first-year students to some value greater than 0.57. Okay, so that's all that means. But because it's type 1 error, when in fact the new program has not helped increase rates. That is, again, the interpretation of a type 1 error in this situation. That is a type 1 error. But there's another thing called a type 2 error. Again, type 1 just means we find evidence to reject the null hypothesis. But the reality is the null hypothesis is correct. And the chance of this happening is significance level. So these two are playing. So one thing you could be, if you try to lower the chance of committing a type 1 error, that means this value will have to get smaller. So if you don't want to commit type 1 error, just make this smaller, which, okay, will and make also rejecting this harder, right? So that's what, so you'll try and protect this by making significance level smaller. So type 1 error, when you're conducting hypothesis, is something you have to be aware of.